How does skydive work? Do you want to join the challenge? Care to learn a little more about the science of skydiving? The study of physics concentrates on matter and its motion through space and time. For our little lesson on the physics of skydiving, we will focus on how the body experiences freefall, and a little behind-the-scenes look at parachute physics. Terminal velocity. After exiting the aircraft, your body will rapidly pick up speed as you fall toward the earth, and within about 10 seconds, you will reach your top freefall speed. This is also known as terminal velocity. Terminal velocity is the point at which there is no further acceleration and is the speed reached where the force of gravity is equivalent to the amount of air resistance encountered during freefall. You see, open air isn't really empty. It is filled with countless air molecules. As you freefall during your skydive, your body collides with these particles and encounters resistance. This air resistance then creates an oppositional force to counter the gravitational pull of the Earth. The counterforce of air resistance is why freefall doesn't really feel like falling at all. That's right. Skydiving freefall feels more like floating than falling. Generally, the terminal velocity that is reached by a belly-to-earth skydiver is 120 meters somehow. However, by changing body position and adjusting the amount of surface area exposed to the air, you can significantly decrease the amount of air resistance and increase terminal speed. The thrill of freefall is only half of the skydiving physics equation. There's also the physics behind parachutes to consider. Parachute physics mimic the physics of flight for a small fixed-wing aircraft. As a matter of fact, within the industry, jumpers often refer to their parachutes as wings. Generally speaking, the square elliptical sport parachutes that are used today are modeled after an airfoil that, when inflated, produces an aerodynamic force. The wing shape of the parachute causes the air to move more quickly across the top of the parachute than it moves across the bottom. According to Bernoulli's principle, the faster air that flows across the curved top of the parachute decreases the air pressure on the top. Conversely, the air flowing across the flatter bottom of the parachute either retains the same level of pressure or marginally increases. As a rule, these forces aim to balance out, with the higher pressure air always moving toward the lower pressure air. This means that the air below the parachute wing pushes upward toward the air on the top of the parachute. Trapped in the middle, the parachute wing is then lifted by the force of the air. While you will eventually be drawn by the force of gravity to the ground, instead of merely drifting down, you can actually fly and maneuver around with a modern sport parachute. There's no need to worry that your parachute won't deploy, as you'll be free-falling with not one, but two parachutes. Plus, they're both packed by a certified professional to ensure proper deployment. A third parachute that we use is called a drogue, which will inflate right after you exit the aircraft. Its job is to regulate your descent and keep you belly to ground. At 5,000 feet above ground, it's time to deploy your main parachute. This chute is the large rectangular canopy we described above, and helps you get to the ground safely. During almost every freefall, these two parachutes are all you need. Every skydiving system is also equipped with a reserve parachute, packed neatly in the top portion of the backpack. This backup canopy is just like the main parachute, waiting in the wings as a precautionary measure. They're rarely used, as the modern-day tech of our parachutes is insanely savvy, though each reserve canopy is inspected and repacked every 180 days regardless of if it was deployed. The majority time, your trained tandem instructor will know exactly what to do in the event of a malfunction and be able to fix it. But should the reserve be the safer option, it's a simple switch. So seamless, you'll likely never even realize they used it. Most skydivers will manually deploy their parachutes. However, each system is equipped with a handy device called an automatic activation device, AAD. Should your tandem skydiving instructor be unable to deploy the parachute and you forget everything you learned in your pre-jump class, both of which are highly unlikely, Your AAD will be there to monitor your altitude and rate of descent. This device will be programmed to trigger deployment at a set height above ground and get you to the ground safely. How do the lines function? Your parachute is tethered to you with strong parachute lines, which include handles to help you or your tandem partner navigate in the air. These glorified strings work just as you might imagine. They pull on certain parts of your chute to guide your direction. Pulling the right side of your lines moves your parachute to the right, while pulling left guides you left. If you pull both at the same time, flaring, that'll slow down your descent, since this causes your canopy to reduce its rate of descent. How does the parachute collapse? The dreaded landed. Many first-timers are most intimidated by reaching the ground. But luckily, your skydiving parachute does wonders in promising a gentle touchdown. Your tandem instructor will know exactly how to flare the chute to encourage a slow and graceful touchdown. These are experienced experts who have performed thousands of safe landings and will ensure your descent rate is smooth and that your parachute brings you down for a soft landing.
That's all the information that we have for you today. Don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit the bell so you never miss out on future episodes. And be sure to also tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. As always, thanks for watching, and we will see you next time.